In this video, we will practice our integration skills, especially integrating using natural logs. For number one, I will start by rewriting the integral using what I call the a plus b over c rule. I can rewrite this as a over c plus b over c. In a similar way, we can rewrite the original integral like this. Simplifying, we have the integral of, and 6 divided by 3 is 2, which I'm going to put off to the side. I'm going to leave this x in the denominator as 1 over x. And then for the next term, we have 3x. We are about to use a memorized rule, so I'm going to mention it now. The integral of 1 over x is the natural log of the absolute value of x plus the constant of integration. So integrating term by term, for the first term I'm going to leave the 2 in the front, and then the integral of 1 over x, as I mentioned, is the natural log of the absolute value of x. The plus c will come later. Moving on to the 3x, I'm using the power rule of integration. So that x is going to become x squared, and then you divide by your new exponent. So that'll give me 3 divided by 2 plus c. So this is the final answer. For number 2, I feel some U substitution coming on. The U is usually whatever is underneath the radical here. So let's take a guess and see what happens. U will equal 6 plus 9x squared. And in that case, U prime will equal, let's see, 2 times 9 is 18. So U prime is 18x. Then what you do is, you do that substitution. So I have 3x, and then the stuff under the radical is that u, so I have the square root of u. Instead of dx, I write du divided by u prime, which is 18x. Now, I notice that I have x in the denominator and x in the numerator, so those are gone. I'm also taking a look at my 3 over 18. That's going to reduce down to 1/6, which I will put out in the front. So now I have 1/6, the integral of the square root of u. I'm going to rather write the square root of u as u to the 1/2 power. Now I can use the power rule of integration. What you do is you add 1 to the exponent. That's going to give me 3 over 2. And then you divide by the new exponent. Dividing by 3 over 2 is the same as multiplying by the reciprocal, which is 2 over 3. Don't forget about the 1/6 that's out in the front. That's still there. So I have 1/6 times this, and then plus the constant of integration. I'm going to reduce this a bit. 2 goes into 6 3 times. So I'm going to end up with 3 times 3, which is 9. So on the next step, I have 1/9. Instead of u, I will put back in the 6 plus 9x squared. And then I have my 3/2 power plus c. So there's your final answer. Number 3 will require the memorized rule that the integral of 1 over u du is equal to the natural log of the absolute value of u plus c. Keep that in mind. You will see that soon. Let's do U substitution. Let's let u equal the entire denominator, which is very common. So I will let u equal 6 plus 9x squared. that means that u prime will equal, well, the derivative of 6 is 0, and then 2 times 9 is 18, so u prime is 18x. Let's make the substitution and see what happens. So I have 3x over u. Then instead of dx, we will write du divided by u prime, or 18x. Notice that we have an x in the numerator and an x in the denominator. Also notice that we have 3 over 18, which is 1 over 6, which we can put in the front. So now we have the integral of 1 over u du. So here's where this memorized rule comes in. The integral of 1 over u du is going to be the natural log of the absolute value of u plus c. And I still have the 1/6 in the front. So that gives me 1/6 natural log absolute value of 6 plus 9x squared plus c. Kabam! There you go. Number 4, let's hit up this u substitution again. Probably u will be everything inside of this radical. So u is 6 plus 9x squared. Deja vu, man. U prime is 18x. Let's get it. So we're going to have 3x over the square root of u. Instead of dx, we will write du over u prime, or 18x. Oh look, the x's cancel out. And hey, we have 3 over 18, which is 1/6, which we will put in the front. So we have 1/6 times the integral of 1 over the square root of u du. Last time when I saw something similar, I used the rule where the integral of 1 over u was natural log absolute value of u plus c. But guess what? I'm not going to do that this time. Because of the square root, this changes things. So I'm going to just rewrite this a little bit as a 1/6 times the integral of, and of course the square root is the 1/2 power, and because it is in the denominator, it would be the negative 1/2 power. So in this form, I can use the power rule of integration. If I add 1 to this exponent, I have positive 1/2. Then you divide by the new exponent. Dividing by 1/2 is the same as multiplying by 2. So multiplying by 2 would be like having 2 over 6. So maybe you'll let me just do that mentally. 2 over 6 will become 1/3. And then plus c. Remember that u is 6 plus 9x squared. So I will have 1/3 times 6 plus 9x squared to the 1/2 power. And yes, I could have put square root over this if I wanted to, but for now, I think I'll just leave it like this. When the degree of the numerator is higher, and you can't do that a plus b over c rule, you probably will have to do long division, which isn't that bad. So you put your x plus 4 in the front, and then your division symbol, and then we will have x squared plus 8x plus 21 on the inside. So x squared plus 8x plus 21. Look at the first term and ask yourself, x times what will be x squared? And of course the answer is x, and I like to line that up with like terms. Then you take this answer and do the distributive property right through here. So x times x is x squared. X times 4 is 4x. And then you subtract. So, x squared minus x squared is 0. 8x minus 4x is 4x. And you bring down the 21. And start over. So ask yourself, x times what will give you 4x? And the answer is 4. And you once again do the distributive property like this. So 4 times x is 4x. And 4 times 4 is 16. And then you subtract. So that's going to give me 0, but 21 minus 16 is 5. And this is the remainder. So you take your remainder and you add it on to the end as a fraction. You do 5 over the divisor. So 5 over x plus 4. The original integrand can be written as this. So the problem now becomes this. I'm going to take this 5 and put it off to the side so it's easier to see what I'm going to do. Don't forget this memorized rule, which we will need when we get to the third term. So the integral of x is x squared, and then dividing by 2, I will put the 1/2 in the front. The integral of 4 is 4x. When we get to the third term, I see that 5 there. I'm just going to keep the 5. And now I'm integrating the 1 over u. So I'm doing a mental u substitution because u is equal to, because u is equal to x plus 4. That's how I'm treating it. And u prime, therefore, would just be 1. That's why I can really do this mentally, because the u prime isn't going to affect anything. All right, it's just a 1. So I will just treat the x plus 4 as a u, but nothing really changes except for that. So we know that the integral of 1 over u is natural log of the absolute value of u. So the integral of 1 over x plus 4 is going to be the natural log of x plus 4. The absolute value of x plus 4. And don't forget your constant of integration. So there you go. That's the answer. When the degree of the denominator is 1 more than the degree of the numerator, we can usually get by with U substitution. We just let the entire denominator be u. So u will be x squared plus 8x plus 21. And then u prime will be 2x plus 8, which, by the way, factors to 2 times x plus 4. So let's make the substitution. So we have the integral of x plus 4 over u. Instead of dx, we write du divided by u prime, which is 2 times x plus 4. So we'll have 2 times x plus 4. And oh look, we have x plus 4 in the numerator and in the denominator. These will cancel out. We also have this 2 in the denominator, which we can put in the front on the next step as 1/2. So now we have 1/2 times the integral of 1 over u du. Memorized rule. The integral of 1 over u du is the natural log of the absolute value of u plus c. And of course we have the 1/2 in the front. Putting this trinomial back in for u, we have 1/2 natural log absolute value of x squared plus 8x plus 21. Did I say absolute value? Plus c. And that's it. Number 7. Sometimes we are asked to solve a simple differential equation. But really, this is just an integral problem in disguise, because solving a differential equation means turning f prime back into a regular f. And if you take the integral of f prime, you get regular f. So I'm going to take the integral of both sides of this equation. And integrating the left side, like I said, I get just f of x. So on the right-hand side, right now, I have the integral of 2x over x squared minus 1 dx. Let's go ahead and do a U substitution, letting the denominator, which is 1 more than the numerator, let's let the denominator equal u. So u is equal to x squared minus 1, which means u prime will equal 2x. Let's make that substitution and see what happens. So f of x will equal the integral of 2x over u. Instead of dx, we will write du divided by u prime, which is 2x. Very nice. I see that we have a 2x in the numerator and the denominator, so those are gone. And then we have f of x equals the integral of 1 over u du. So we will definitely use the memorized rule, which says that f of x will equal the natural log of the absolute value of u plus c. So let's go ahead and substitute x squared minus 1 back in for u. So now we have this. The differential equation has not been solved until we find the value of c. We will use this initial condition in order to solve for c. So let's start by just writing this down. F at radical 2 is equal to 5. So what is f at radical 2? Well, that's what you get if you plug in radical 2 for x. So let's do that. So f at radical 2 would be the natural log of the absolute value of radical 2 squared minus 1 plus c. And f at radical 2 equals 5. So all of this should equal 5. If you square radical 2, you get a 2. So now we have the natural log of 2 minus 1 plus c is equal to 5. 2 minus 1 is 1. So this is the natural log of 1, which hopefully you know to be 0. So I have 0 plus c is equal to 5. So in other words, c is equal to 5. Now we can substitute 5 for c to get the final answer. So f of x equals natural log absolute value of x squared minus 1 plus 5. That's the answer.